All right, section 3.4 is on independence, and we have been talking about this. So what's kind of nice about coming out of spring break is this will be a good review, but it might not feel like it because you've had a whole week off. So independence, how do you know if two events are independent? I'll give you a second to think about this. And again, this is nice thing is this is a video, so you can pause it and think about it. So two events are independent if the probability of each event multiplies to the probability of both events occurring, probability of A and B. Now we talked about this before spring break, so it's probably in one of your earlier note sheets, but a really good thing to highlight for your test coming up this week. So box in that formula because you'll be asked to verify if two events are independent quite a bit. So there are lots of ways to express probability. So I'm just going to kind of remind you, starting out with the basic, like, hey, here's probability in front of you. Like there's no Venn diagram or tree diagram or anything to express it. So this is showing the probability that a student is in choir or band, neither choir nor band, or both choir and band, just to give you a little context. And we want to know if the two events are independent. So again, if the events are independent, when you multiply the probabilities together, they should equal the chance that they're both, of the probability that they're both. So if I do the probability of choir times the probability of band, does that equal the probability of being both in choir and band? So I don't really need the neither information. You can just kind of cross that off your notes if that confuses you. So being in choir is 55%. The probability of taking band is 65%. And the probability of taking choir and band is 50%. So you can just see those numbers. They're all given. So this is pretty easy, right? Just kind of plugging it in. If you grab your calculator and multiply 0.55 times 0.65, you get 0.3575. It's supposed to equal 0.5. So what does that tell you? It tells you that being in choir and being in band are not independent events. Okay, you try this one. Pause the video. So is playing soccer and playing golf independent of one another? So again, if so, the probability of playing soccer and the probability of playing golf should multiply to the probability of playing soccer and golf. So soccer was 50%, golf was 40%, 0.5 times 0.4. The probability of playing both was 20%, 0.2, and 0.5 times 0.4 is 0.2, which tells you that playing soccer and playing golf are independent events because they equal. Now, just a disclaimer, if these two numbers, 0.02, 0.02, if they're real close, like if this was 0.19 and this was 0.12, you could still consider the events independent if they're close enough to being equal, okay? Okay, the second way we looked at data in terms of expressing its probability is out of a two-way table. So this table is showing the number of people that have cable TV versus not keeping cable TV. And then if they took a vacation or if they did not take a vacation during a specific time period. And I have the totals all filled in for each of the rows and the columns. And then, of course, the grand total of 166 down there in the bottom right-hand corner. Okay, so are taking vacations and having cable TV independent? So taking vacation, having cable TV, we're really only focused on that. So I don't really care about the people that don't have cable or don't take vacations, right? So if you, again, revisit your independence formula, we want to show that the probability of taking a vacation times the probability of having cable television is the same as the probability of taking a vacation and having cable TV. So if you come over to the table, the probability of taking a vacation, if I go to vacation and find the total, which is 111, and then I can divide that by the grand total of people, that's 166, right? And then, sorry, I have all the numbers filled in, but probability of having cable television, here's cable TV. If I go to the end, all the people that have cable television are 135. out of 166, so that's that second fraction. And then the probability of having cable TV and taking a vacation is where they intersect. So taking a vacation, having cable television, they intersect at 97. And that's also out of the 166. Now, just be careful when you type these values into your calculator. So I kind of take them one at a time. So 111 divided by 166 is 0.67. 135 over 166 is 0.81. And then I multiplied those together, if you can see through my red X's, and I got 0.54. And then 97 over 166 is 0.58. So they aren't equal and probably not close enough. So I would say that those two events, taking a vacation and having cable television, are not independent. Okay, then this is also review. So I just wanted to remind you of this terminology, I guess, one more time. So mutually exclusive events are two events that cannot happen at the same time. So here are some examples, right? If you flip a coin, there's no way you're going to get heads and tail on the same flip. You're going to get one or the other. You can't be taking FST and pre-calc right now. You can't drive to school and walk to school at the same time. So all of those events are mutually exclusive. Like you can own, like they would have no overlap, right? Visually speaking, if you have mutually exclusive events, because they have no overlap, the two circles in the Venn diagram would not overlap. So that's probably pretty straightforward. Okay, and then I guess I probably should have started with this, but your and versus or notation, remember your or notation is like a U symbol. So if you see probability of A or B, that's the probability of either of them occurring. It could be one, it could be both, but that's what or means. And is upside down U. And that has to be literally the probability of both of them occurring at the same time. So mutually exclusive events don't have an intersection, right? And if it helps you keep it straight, remember and, you can kind of make the A. So or is the U, and is the A, if that helps you. Okay, we're going to get a little bit into conditional probability, which again, we did talk about before spring break. So when you have a table, just remember if your totals are missing, take a second and fill them in. You're gonna need the totals for sure for any kind of probability. So this data table is showing age groups like under 30, 30 to 45, over 45, and then if they're liberal versus conservative, what do they consider their kind of political view? So if you take a moment and fill in the totals, and go ahead and pause the video if you wanna just double check my math. Here are my row totals, which is the age totals, and my column totals, which is the political preference, and a grand total of 1,500. Okay, so now if you're asked questions like, what is the probability that you are liberal, and remember U is or, liberal or over 45. So if I go to liberal and I go to 45, they intersect at 280 people. You see that? Liberal over 45. Okay, but that's the intersection. And or means I could be either full-on liberal, don't care about the age. I could be full-on over 45 years old, and I don't care about political preference. Or it could be the combination of both, the intersection. So remember, when you have an or situation, it's a lot more involved, right? So the liberal, there are 725 liberals. And over 45s, there are 690 of them. And that totals 1,415. Now the tricky part, and this is incorrect, the tricky part about that is you need to subtract out the overlap, right? Because the over 45 and the liberal, I got that 280 in there twice. So if I take this chunk out, actually I'm just going to type it because I thought I finished this and I didn't. So 14, 15, and I'm going to subtract out that extra 280 that I got in there twice, and then I'm going to divide that by the 1,500. Okay, that's going to be your total probability. And let me just make this line a little bit longer so you get that idea. So again, the 1415, that number included the 280 that was a both liberal and over 45, and I got that in there twice in both of these two fractions that I added, so I have to subtract out the extra one that I got. So if I subtract the 280, and you double check my numbers, but I'm going to subtract 280 right now, and then I'm going to divide that by 1500, and I get 0.7566 repeating. So I'll round that, I guess. So that would be your, there we go, your final probability right there. Okay, so that's that could be tricky. Just remember or is either. Another option, of course, is you could just add up all of the liberal pieces and the over 45 pieces and then just not count that 280 twice, and you should get that same grand total that this would be. Okay, so then what if you have liberal and over 45? So let me go back to full screen here. So liberal and over 45 would be both, right? And is their intersection. So liberal over 45, they intersect at 280. So that's pretty straightforward, right? 280 out of 1500. Whoops, sorry, let me go back. And there's the decimal approximation. So that's like around 19%. Okay, so or versus and. Then we have the conditional probability, and remember this line right here, that means given. So what is the probability that you are a liberal given you're over 45? I only care about the over 45s. If it's given that I'm over 45, I'm not looking at any other group. Okay, so if you recall, in a table, I go to liberal and over 45, which is still that 280 intersection. But now I'm not dividing by the 1500, I'm only divided by the condition that it's based on. And it's conditional that I'm over 45. So the total of the over 45s, if I go to the end of that column, is the 690. So be careful with that condition, right? That's true conditional probability. Okay, you tried this one. Pause the video and just make sure you get this. What is the probability that you're over 45 given you're liberal? Okay, so over 45 and liberal, again, intersect at the 280, but now it's given that I'm liberal. So I only care about the liberals, which is a 725 total, and that changes that probability, of course, right? So whatever the condition is, whatever follows that slash, that given, that's what you divide by, that total, right? Liberal total, 725. Okay, then, of course, we got to end with this table with independent events. So are being over 45 and a liberal, are they independent of one another? So remember that if two events are independent, right, remind yourself this formula, then the probability of being over 45 and liberal should equal the probability of being over 45 and liberal. So I listed these two probabilities here. The probability that you're over 45, go to the end of the column, that's 690 out of 1500. What's the probability that you're liberal? Okay, so go to liberal, the end is 725 out of 1500. And then I want to know if those two multiplied together equal the probability of being 45 and liberal. Now we just did this on one of the previous slides, but again, and means they're overlap. So that's going to be the 280 out of the 1500. So if I move this, just to remind you, that's the intersection, right? So I want to show that this times this equals this. Okay, so if I set up the math, it would look exactly like this, right? Is the probability of being liberal, 725 over 15, times over 45, 690 over 1500, is that equal to the intersection? So again, you pick up your calculator, you carefully type in these numbers, and I kind of multiplied those out already, but you can verify. And I got 280 over 1500 to be about 19%, which does not equal the product of these two. It's not close enough. If it's close, I would say like 1% or less. So these two events are not independent. Okay, so here are your conditional probability formulas. If you have a table, it's easy to kind of pick that out because you're just looking for row and column totals. If you don't have a table, because we're going to end with Venn diagrams, then you really need to understand the actual formula that you're applying on those tables, even though you probably didn't realize it, right? So conditional probability, remember, has this little slash here. So this means what is the probability of A given that B has occurred? So you find the probability of their intersection, and then remember, you always divide by the conditional piece. So if it's slash B, you're dividing by the probability of B. So if I flip these, look at the second formula. If I flip A given B to B given A, the numerator didn't change. It's still the intersection between these two, but now I'm dividing by the probability of A. So really, if you just write down one of these formulas and know that whatever the denominator is whatever the condition is. The numerator is always the intersection between the two. Okay, so let's look at this. I'm going to give you a second to make sure you can actually construct this Venn diagram before I pick it apart. Okay, so 35% of students take FST, 30% of students take chemistry, and 20% are taking both. Okay, so if you want to, pause the video and create this Venn diagram, and then I'll carry on. Okay, so here it is. And remember, when you have a Venn diagram, you always start with the both. So both of them are taking FST and chemistry is 20%. That goes in the middle of the circles. You have an and, right? An intersection. So if 35% are taking FST, remember that's the whole circle for FST. So if 20% is already in there, then the outer part of the circle, kind of this moon piece, has to be 15%. Because 15 plus 20 is the total of 35. Same with chemistry. Chemistry is 30%. So since 20 was already in the overlap, I only need 10 more percent out here to make 30% chemistry. And if you add up your circles, 15 plus 20 is 35, plus another 10 is 45. That means the remaining 55% aren't taking chemistry or FST. Okay. So let's finish these off then. So what is the probability that a student is taking FST or chemistry? Remember, U means or. So or means I could take just FST, I could just take chemistry, I could be taking both, right? Or is real flexible. And the nice thing about a Venn diagram is you can just add those up, right? So 15 plus 20 plus 10 is 45% taking FST or chemistry. Okay, what's the probability of taking FST and chemistry? Well, and, remember upside down U, and that's the intersection, and so you don't have to show me any math there, right? That's just going to be the intersection of 20%. Okay, so what is the probability that you're taking FST given you're taking chemistry? So now I'm using this conditional formula. A might represent FST, and B would represent chemistry. So first I want the intersection between FST and chemistry, and I found that to be 20%. Then I want to divide by the probability of the probability of taking chemistry, which remember is the entire circle of chemistry, so 20 plus 10 is 30. So the math again is the intersection, A and B, FST and chemistry is 20, divided by the probability of the conditional, which is just chemistry, and that's 30. So about 67%. Okay, what if I do the reverse? Why don't you pause and try this one? Okay, so chemistry given FST is still the intersection between the two, so still 20%, but now I'm dividing by the probability of FST, which is the whole FST circle, so 15 plus 20 is 35, so 20 divided by 35 is about 57%. All right, then the last couple here, we'll just change it up a little. What's the probability that you're taking FST given you're not taking chemistry? Okay, so where does FST and not chemistry overlap? Well, chemistry, if I have this circle here, I don't want it, right? So anything but this circle is not chemistry. So where does FST and not chem overlap? That would be the 15% part of FST, because the 55% stuff down here is overlapping with chemistry. I don't want chemistry at all. Then I want to divide by the probability of not being in chemistry. That's my condition. So not being in chemistry is everything except this circle. So everything except this circle would be the 55 on the outside and the 15, which is 70%. And you divide those out. All right, and the last one, again, I'll let you try this. So pause it, see if you can get this one. So the probability that you're in chemistry, given you're not taking FST, so chemistry and not FST. Okay, so chemistry is this circle. I don't want FST in there. So take out the FST circle, and that leaves me with just the 10% of pure chemistry. Then I'm going to divide by the chance that I'm not taking FST. So I don't want any of the FST circle. So that's going to leave me with the 55 on the outside plus the 10 of chem. So 65, and that leaves me with 15%. So again, I know the nice thing about videos is you can pause, you can go back, you can re-practice these. But if you feel good about this, that's a good sign for your test on Thursday, because a big chunk of your test is showing all these probabilities with Venn diagrams and charts, independence, conditional. So you got this, right? So you can start on your homework and start preparing for the test anytime you're ready, and I will see you soon.